name you can say is circular motion. Circular motion. So in circular motion, first we will discuss the kinematics of the circular motion. What is the meaning of the kinematics? Here we will not talk about the cause of the motion. Cause of the motion, that is force. In the kinematics of the circular motion, we will not touch force. We will only discuss the displacement, speed and acceleration. Displacement, speed and acceleration. So, for example, first term in the circular motion is the angular displacement. Angular displacement. So, in the straight line motion, we have the displacement, and here is the angular displacement. Okay, so now see what is angular displacement. So, this is a circular path. This is a circular path, and this is a person. This is a person, and this person, suppose, started the motion from this point A, and this is the center of the circle, and you are watching this motion. This is the observer. This is you, and you are watching this motion of this person. This person is moving in anti-clockwise direction from A to B. Okay, in a on a circular path, this person is moving. So initially the person is at A, finally the person reached to the point B. Okay, so initial point is this and final point is this. So this is a circle. So this will be the radius of the circle, and this also will be the radius of the circle. Okay. And you are watching the motion of this person. Here is the person. This person is basically here. Okay, so okay. This person is basically here, started the motion from A and finally reached to the final position at B. Now, when you are watching this motion of this person, so you will see this person is subtending an angle that is known as theta. This person is subtending some angle theta, and this theta is known as the angular displacement. This theta is known as the angular displacement. This theta is the angular displacement. You are watching like circular motion, some body is moving like this. So you will watch the motion like this. Okay. So your neck will be like this. Your head will be moved from down to up like this. So basically, the angle subtended by the person will be the angular displacement. Okay. So the person initially at A, finally at B, and this theta will be the angular displacement in the simple word. Now measurement of theta. Theta is basically some angle. Theta is some angle. 30 degree, 60 degree, 40 degree, 37 degree, 57 degree. So measurement of theta. So how we measure the theta? Measure the theta means what is the unit of the theta? So basically theta can be measured either in radian, either in degree, either in radian, either in degree. So we say na sometimes 90 degree, 30 degree. So 30 is the angle, degree is the measurement. So measurement of theta is either in degree or either in radian, and radian is the SI unit, International System of Units. So basically mostly we will use this radian. Okay, and this angular displacement is a vector. This angular displacement is a vector, and this is a different type of vector than the velocity, than the acceleration we have studied from the force. Force is a different kind of vector, and this is a different kind of vector. Basically, This is theta. This theta is the angular displacement, and this theta is basically the axial vector. We have discussed now there are two types of vector, axial vectors and polar vector. So I have told you that axial vector acts along the axis. Axial vector acts along the axis, I have told you. After that, what will be the direction of the theta? So now suppose this person is moving in this direction from A to B. So can you tell me what will be the direction of the theta? Hiba. This person is moving from A to B in this
Anti-clockwise.
anti-clockwise. Hmm?
Yeah.
No. Basically, the direction of theta we do not define in terms of anti-clockwise and clockwise. Why? Because this is the axial vector. This is the axial vector. So basically, this is the axial vector. So axial vector means this vector will act along a line, will act along the axis. Is there any problem with my video?
It's
Hmm?
blanking out.
Okay. Okay. So now for the direction, if you want to find the direction of this theta, okay. So basically this theta is like this. This is the theta, and this direction of the theta is given by the, there is a rule, right hand thumb rule. Right hand thumb rule. So now how we will find the direction of theta by right hand thumb rule? Right hand, take your right hand and curl your fingers. These are your fingers. Curl your finger along the sense of the motion of the body. Just a minute. So curl your, take your right hand, not your left hand. Take your right hand, curl your finger along the sense of the motion of the body, or along the sense of the direction of, along the sense of the motion of the body, and see where your thumb is going. And see where your thumb is going. Your thumb will tell you the direction of the theta. So what direction you will get? See, curl your finger along the sense of the motion. This person is going in this direction. So curl your finger along the sense of the motion. So basically thumb I am getting towards me. So basically here the direction of theta, the direction of theta will be towards the reader or towards the observer. Towards the reader you can say. And sometimes we say this direction as outward direction. Outward means something is coming out of your screen, out of your copy. If you are just finding the direction of on your copy, so there will be a direction out of your copy. If you are finding the direction on your screen of your laptop, that you can say out of your screen. Clear, Hiba?
Yes, sir.
Okay, if I am saying that, if I am saying that this person is moving in this direction, suppose this person is moving in this direction, then what will be the direction of the theta?
Inward.
Yeah, inwards. Very good. So right hand thumb rule you will apply and you will get the direction of theta. Now there is a relation between the angular displacement, what is angular displacement, this theta, and this distance AB. You can say this as a linear distance AB in a circle. Linear distance in a circle. Linear distance in circle. that is AB here in this case. Okay, two ways to calculate this. Basically what I want the relation between this theta and this distance covered by the body AB. First thing, from the property of the circle, angle is equal to the arc length divided by the radius. Angle is equal to arc length divided by the radius. So this relation is valid. Okay, so this relation will be valid here. Okay, so basically this is AB. So AB is the arc length and R is the radius. Okay, so theta is arc length AB divided by the radius. Okay, suppose this AB length I am saying S. AB is equal to S I am saying. Okay, so I can write theta is equal to S divided by R. Theta is equal to S divided by R. So I can write that S is equal to R theta. So S is equal to R into theta. So I can say this is the relation, S is equal to R theta. One more way to calculate. See, for completing the whole circle, suppose initially this person is at A. For completing the whole circle, how much angle this A will cover in radian? Basically, in covering the whole circle, it will cover a 360-degree angle. Or talking about the radian, 360 in radian is equal to 2 pi. So this is in degree, this is in radian. For completing one circle length, angle will be angle covered by this person A will be 360 in radian, or in degree. In radian you can say it is 2 pi. Okay, so basically for covering the length of 2 pi r, or you can say 2 pi angle will be covered for covering the length of the, what will be the length of the circle? How can we calculate the perimeter or the length of the circle? Do you know? 2 pi r. Okay, 2 pi into r. 2 pi r. So for covering 2 pi angle, the length of the circle is 2 pi r. For covering the unit radian angle, the length of the circle will be 2 pi r divided by 2 pi, that is equal to r. Okay, basically this is the length of the circle, or this is the length of the arc, you can say here, or length of the distance covered in circle. Now for covering the theta angle, the distance will be theta into r. And okay, so now we got it, this AB. So this is the theta and this is the distance AB. So AB you will get this. This is your AB. So this is from the unitary method. This is from unitary method. Otherwise, simply write theta is equal to arc upon radius. Finish. Theta is equal to arc upon radius and finish it. Okay, note down this. Write down the heading circular motion, chapter number has circular motion, and after that write kinematics of the circular motion. Okay, and after that write the angular displacement theta. So in this case, the value or the direction of theta is towards the reader or outward. It can be inward also.
Done, sir.
Done. Write down this also. Scroll down.
Yes, sir.
So, and there is one more point that I want to write. Basically, if you will find the dimension of this theta, dimension. So how can we find the dimension? Theta is equal to arc length. Arc length is also a length. It will be a length, na? Radius is also a length. Radius 5 meter, 10 meter. So this will be L and L. So basically there will be no dimension. M0, L0, T0. So basically this theta is dimension less. This theta is the dimensionless quantity, but this theta have the unit. Okay, this is very rare quantity have the unit but do not have the dimension. So this is dimensionless, but it have a unit. Unit is radian or degree. Radian or degree. Now there is another term, angular velocity. Angular velocity. So before the angular velocity, we should know what is linear velocity or the velocity. What is the linear velocity? Linear velocity is the, if I am talking about the average linear velocity, then you will say total displacement divided by total time. So in the same way, angular velocity is total angular displacement divided by the total time. Okay, so angular velocity. So here you can see linear velocity is the linear displacement divided by time. Okay, linear velocity is linear displacement divided by the time. So angular velocity means this person is here and moved to here, and this person is moving with the angular velocity of omega. This is known as the omega. So angular velocity is represented by omega, and this is like, you can just compare it with the linear velocity. So angular velocity basically is the angular displacement divided by time. So angular velocity is basically angular displacement divided by time. So what is angular velocity? Angular displacement, that is theta divided by the time. Okay, theta divided by the time. Suppose this is the center of the circle, and this is radius, and this is radius. Okay, and this angle is suppose theta, or you can say this is suppose delta theta. And in covering this delta theta, time taken is t. So you can say your angular velocity will be delta theta, or you can write here only theta also. Theta divided by time. Okay, this is your angular velocity. So now velocity can be measured in two ways, either the instantaneous velocity or either the average velocity. So what is the meaning of the instantaneous velocity? Angular velocity at any instant of time, okay, of this person. This person is moving on a circle, again I am saying, and you are observing the motion from here, from the center. So basically angular velocity can be average angular velocity or instantaneous angular velocity. Like average angular velocity is given by the delta s divided by delta t.
So,
Just wait a minute, I am just coming. Yes, what are you saying?
so what does omega represent?
Omega is representing the angular velocity.
But angular velocity is the angular displacement by time.
Yeah, angular velocity is the angular displacement divided by time.
So theta by t is omega.
Yeah, theta by t. This is a general term I have written. Like we say the velocity is equal to displacement divided by time. Na? We say basically, see here. Basically, angular velocity is equal to the angular displacement divided by time. This is clear?
Yes.
Okay. Angular velocity is equal to angular displacement divided by time. But there are two ways to measure the angular velocity. First is, suppose a person is moving and in a circular path, the angular velocity of that person is changing with time. At different time, the angular velocity of that person is different. Then if someone is asking what is the angular velocity of that person moving in a circle, then what you will say? You have to either take the average of the velocity, either you will tell the instantaneous velocity or the velocity at that instant of time. So that is why we define the angular velocity in case in first is average velocity, average angular velocity, and instantaneous angular. Basically, this is not the velocity. Here I will write again. Okay. So this is just the analogy I will use. Okay. This is just the analogy.
So,
Basically, see here. I know what is your doubt.
okay.
Basically, if you will calculate the omega average, then it will be delta theta divided by delta t. If you will calculate omega instantaneous, then it will be d theta divided by dt. Okay. So linear velocity is basically, what is linear velocity? Average linear velocity is equal to delta s divided by delta t. What is delta s? Delta s is basically the displacement. Okay, total displacement divided by total time. Total displacement divided by the total time. Delta s by delta t is total displacement divided by total time. Okay, so average angular velocity is equal to delta theta, total angular displacement divided by total time. Delta theta is total angular displacement. So basically delta theta is total angular displacement. Total angular displacement. Now instantaneous angular velocity. See here, see the linear instantaneous velocity ds by dt. ds by dt means this is the differential form. This is the differential form. Actually, what happens now? What happens when here delta t becomes 0? Delta t tending to 0 means for very short interval of time, delta t tending to 0, then this delta theta and delta t will approaches to, I am writing it again. Okay. So for calculating the instantaneous velocity, instantaneous angular velocity, instantaneous angular velocity. So what happens for instantaneous angular velocity means omega instantaneous you want. So instantaneous means at that instant of time you want, means that delta t time will be very small, that delta t tending to 0. So then you can write the instantaneous velocity as equal to limit delta t tending to 0 and delta theta by delta t. Then you will get this thing, omega instantaneous is equal to this delta theta is converted to d theta. Why? Because in delta t is very less. So in that delta t, d theta is very less. So very less quantity we represent with d theta. So d theta by dt. Okay. So d theta by dt. So remember this and remember this. Unit radian per second. Omega is basically angular displacement divided by time. So it can be written as radian per second. Omega is also the axial vector. Direction of omega is also given by the right hand thumb rule. Right hand thumb rule. Okay, so now you can note down fast. So don't get confused. We will solve the question in the next class. Okay. Okay, write down.